In this demonstration, we will go over different loads, constraints, and simulation object types that you can use in your finite element model. Within the sim, under loads and conditions, there's a set of predefined commands for Simcenter and Astran that you can choose from and easily apply to your model. Once selected, a command is executed and is placed in its respective container in the simulation navigator and its active solution. You can also use Subcase Manager to easily manage what you want to apply to your solutions and subcases. For example, if we had a solution created and we right-click that solution and under Subcase Manager command, that will pull up our Subcase Manager. And here we'll have a list of different loads, constraints, and simulation objects that are in our containers that we can apply to each subcase. A green check mark will show that it's being applied, and a red X will show that it's not being applied. Now, depending on the physics of the problem, there are different loads that you can choose from. Here's a list of loads for Simcenter and Astran structural solution. Some common ones include force, pressure, gravity, and temperature. These can be applied as a scalar value or a table value. For example, let's choose force. We'll apply the force to a face. We'll give it a value, and we'll give it a direction. Now, if we wanted to apply the force as a table, we can go into our load container. We'll edit that force that we created, and under this drop-down, we can select an existing field, or we can create a new table field. Now, under constraint type, there's a list of different structural constraints that we can choose from. Depending on the degree of freedom that we want for our model, we can set it to be predefined, such as fixed, simply supported, pinned, and so forth, or we can choose our own under user-defined constraint. If we choose user-defined constraint, there's a set of 6 degrees of freedom that we can choose to have free, fixed, or a set displacement. Lastly, we can set simulation object types such as glue or contact to our model. You may choose glue if you don't want the interface between bodies to slide or separate, or choose contact if you do. So now let's get into a quick example. Here we're going to go ahead and create a new solution. We'll give it a name. And the solver is going to be Simcenter and Astran. It's going to be a structural solution and a linear statics type. If we were to change it to, say, a thermal or acoustic, rotor dynamics, or aeroelastic analysis, our loads and conditions will update accordingly. So here we'll stick with the structural solution, and now we can see that active solution in our simulation navigator. So first, let's go ahead and apply a gravity load, and we're going to apply that to the whole model. We'll apply it in terms of G's, and we'll say 10, and we'll give it a direction. Here we'll do the -y direction. If we zoom out a little bit, we can see that arrow representation of the gravity load. And next, let's apply a constraint. So here we'll select a fixed constraint, and we can apply this directly to the geometry or the finite element model. I typically like to apply it to the geometry. That way my model stays associative in case I make any CAD changes. So we'll go ahead and apply that. Next, we'll create some simulation object types. Here we'll do a surface-to-surface glue condition. And we'll preview it first, and it picked up a few different pairs, so we can select OK. And we'll give it another search distance of, we'll just keep the default for right now. And now if we look at our simulation object container, we have 4 glue conditions. And it's also being applied to our solution itself. All right, so right now we have our glue, we have our constraints, our loads. Let's go ahead and jump into kind of a side example, and let's clone this. And just want to show that if we were to use the subcase manager, we can turn our loads on or off. We can do the same for our constraints or our simulation objects. So if I didn't want a specific glue or contact to be on during this subcase, I can turn it on or off this way. And this really helps manage those solutions with a ton of subcases or many different boundary conditions. So I'm going to delete this solution I created, and now let's go ahead and solve the model. And that brings us to the end of this demonstration.